Hello, Algebra 2 or Pre-Calculus student. We are talking today about analyzing the graphs of polynomial functions, and specifically I made this video so that I could go back through finding all of these things that we talked about in class, but specifically showing on the graphing calculator how to find the things that we need to find on the graph using that calculator technology. So basically, this is the same thing as what you're going to be told to do for your homework. You're going to be given a polynomial equation, and it probably should say for each function. For each function, you're going to graph it on the calculator. You're going to find the min and max points. And really, we're going to also label whether they're a local min, which means the same thing as relative min, or a local or relative max, or if it's an absolute min or max. We're going to look at the x-intercepts, which are basically the zeros, at least the ones we can see, the real zeros, and y-intercepts, just because we're throwing these in there to help us be able to do this, which is sketch the graph, labeling all these significant points. We just want to have some idea of where the graph goes. And then we're going to describe the intervals of increase and decrease. That's something we talked about in class today, in interval notation. Describe the domain and range in interval notation as well, and give the end behavior. Even though we're already looking at the graph, so we already know what it does on the ends, I want to make sure you practice writing what happens on the ends. So this is what we are about to do. All right, so first off, take your pick as to which one we're going to say. I am having trouble finding the graph I wanted to use first. So let's just go with this one. One sec. I want to make sure this one does what I want it to do. So, sorry. I don't want to hold you off too long here, but just bear with me one sec, and yeah, that works. Okay, so first one we're going to look at is f of x equals negative x cubed plus 4x squared minus 5. All right, so in the graphing calculator, first thing you want to do is you want to touch this button right up here that says y equals. And that gets you to this screen where you can see all the different y equals. You got y sub 1, y sub 2, y sub 3. This is so you can put in different equations, but we're probably only going to use it one at a time. And then I'm going to type this in. The x is right up here underneath mode. Okay, and if I want to do something other than squared, I have to use this caret button, the one that looks like a rooftop, to raise something to a power. So in other words, here I'm going to say negative. Don't forget to use the negative, not the minus. Negative x to the third, and then I press the right arrow to get out of the exponent area, out of the superscript, plus 4x squared plus 4x squared minus 5. Excuse me. And now I'm going to hit graph. Now one thing you can hit instead of graph, I like to always go to the standard window first, and that's what this is showing. If your graph is not showing the standard window, instead of graph you can hit zoom 6, and it'll take you to the standard window. The standard window goes from negative 10 to 10 for x and negative 10 to 10 for y. Okay, so I want to find on this graph some significant points. And really what I'll probably do is, before I sketch it accurately, I'll probably just sketch it a little bit here so I can label the points as I find them. So this is basically just the general shape that I have. And I'm going to go ahead. First I'm going to find the zeros, the x-intercepts. So here where it says trace, above there it says calc. When I press second, trace, if I want to find a 0, that's 2. So if I hit the button 2, I don't have to press enter. Left bound, what this is asking me to do, and I'm using the left and right arrow buttons here, is to move to the left of where I think this place is, and then move to the right of where I think this place is, and then for guess I'm going to press enter. So I pressed enter 3 times. First I moved to the left of the 0, and then I moved and pressed enter. Then I moved to the right of the 0 and pressed enter, and then I pressed enter. And it's telling me that I have a 0 at -1, 0. So there's 1, 0. And let's go ahead and keep finding the zeros. So left bound, I'm going to move to the left. I'm looking for this guy. So I'm going to move to the left of that and to the right of that and press enter each time. Let me see if I can come up a little bit more. It's not going to be well. I'm sorry. I need to move to the left of that 0 and then to the right of that 0 and then press enter. And I get a 0 at 1.38. And then my last one here, second calc 0, left bound. I got to get over there close to that 0. Left of it, enter. Move to the right, enter. Press enter for guess. And then I've got 3.62. 0. I know that the y value should all be 0 because these are the zeros. Now I'm going to find this local min and this local max. This is getting a little messy. Same place, second trace, minimum. I'm going to press 3, so I'm going to be looking for this guy, this local minimum. So I'm going to move my cursor over to the left of that minimum and press enter. And then I'm going to move it to the right of that minimum and press enter again for the guess. And my minimum is 1 point. Now look at this. This is really interesting. Don't know how well you can see it. Probably not much better for me moving it up. It says 1.6438 E -6. If you see an E anywhere in that number, basically near the end, that's actually scientific notation. This is saying 1.64 times 10 to the -6. So 0.00001.164. Okay. So in other words, the x value there is 0. If you see an E, pretty much it's 0. It's just so small, it's a pixel issue that the calculator can't quite get to 0. So this is 0, -5. That's my local min there. And my local max for this graph, second trace, maximum is 4, so I hit 4. And then I go over to where that high point is, and I go slightly to the left of it, hit enter. To the right of it, hit enter. Guess my max is at 2.67 and 4.48. Okay, so find the minimum and maximum points. I've got, I'm going to say local min is at 0, -5. I have a local max at 2.767, 4.48. Keep in mind the min is actually the y value and the max is actually the y value. X-intercepts, we already found those. Oh, we forgot. No, we didn't forget to find the y-intercept because there it is. Since the x value here is 0, we've got it. We forgot to find it deliberately, but it's there. So x-intercepts are at, excuse me, -1, 0, 1.380, and 3.620. And the y-intercept is at 0, -5. Sketch the graph labeling significant points. So that basically just means do a better job than this. Let's go ahead and just make it a little bigger. I do mean kind of rough sketch when I say this. I want to put all those points on there first that I know it goes through. And here we go. Sorry, I didn't go through that one very well. Let's pretend I did. There is my sketch. Okay, I need to go through all those points. Describe the intervals of increase and decrease. Excuse me. Here are my turning points. I have 2 turning points, so that means I have 3 different regions of the graph. I have an interval of decrease over here. Excuse me. This is like a guy walking downhill. From negative infinity to 0. We only use x values to describe where it decreases or where it increases. This is increasing from 0 to 2.7. And again, it's decreasing from 2.67 to positive infinity. So those are my intervals of increase and decrease. Describing my domain and range. My domain for any polynomial function is all real numbers. So that's going to be negative infinity to positive infinity. My range, the range is only limited if I have a ceiling or a floor, a maximum value or a minimum value that is the absolute maximum or the absolute minimum for the whole graph. I don't here. This keeps going up and up and up to the left forever and down to the right forever. Okay, so if there's no limit on the range, again, all real numbers. And finally, end behavior. Let's go ahead and describe this end behavior. The end behavior of this graph, we would say, as x approaches negative infinity, which is a way of saying on the left. As x approaches positive infinity is a way of saying on the right. This one points up on the left, so f of x approaches positive infinity. I'm sorry, that didn't need to be there. And down on the right, f of x approaches negative infinity on the right. All right, there you go. That's one example. I will come back with more in another video.